In this movie, I'll show you how upsampling has improved recently in Photoshop, and I'll also show you how it compares to capturing high-resolution data with your scanner or digital camera in the first place. Notice that I've got this image right here called duplicateimage.tiff, and I created it just by going to the previous image, clicking on the image menu, and then choosing this command right there, duplicate, which creates an independent copy of the image. And I'm doing this, of course, for comparative purposes. So now I'll upsample it by returning to the image menu and choosing the image size command. I've still got my whopping big image size dialog box. And I'm first going to make sure my resample image checkbox is turned on, and then I'm going to increase the resolution value to 1,000 pixels per inch, which is way more than we need for print. However, it provides us with a useful demonstration. Now, thanks to the fact that I can't see the image in the background, I'm just going to have to manually drag inside the image window in order to see the Tyrannosaurus Rex here. And notice those are the pixels if we were to just magnify them. And this is the interpolation, that is the method by which the pre-existing pixels were averaged in order to create the new ones. Now, this is different than it used to be, by the way. I'll go ahead and move things over a little bit there. Notice next to the word resample is an interpolation method. By default, it is set to automatic, but you can choose between a lot of other ones as well. Automatic, when you upsample, is the same as choosing preserve details. It used to be, however, the same as choosing bicubic smoother, and I just want you to appreciate what a big difference this makes. So in previous versions of the program, you would have gotten this. That is very soft detail. Possibly, you might argue, it's better than a bunch of jagged blown up pixels, but there's no denying that it's something of a blurry mess. Whereas now, we have preserved details, and you can see that that makes a terrific difference. We get some nice hard lines and some smooth lines as well, and it does a very good job of drawing in circular areas, much better than in the past. And you can see that's the same as choosing automatic when upsampling once again. There is one advantage, however, to selecting preserved details manually, and that's that you also get this reduce noise slider. I'll go ahead and scoot this image over even a little more. And notice as you crank that up, you start getting rid of the transitional pixels right there. So you're smoothing over the rough transitions. And you can take this value all the way up to 100% in order to get the smoothest results possible. In my case, that noise is actually paper texture, so I don't want to lose it, which is why I'll go ahead and scoot the reduced noise value down to 0%. And I might as well just stick with automatic as well. All right, now I'll click OK in order to scale the image, and it's going to grow dramatically as we're about to see here. And you can expect this to take a few moments because Photoshop is generating 10 pixels wide and 10 pixels tall, so 100 pixels for every 1 pixel we had before. All right, now I need to find out where the heck I am in this document. So I'll press and hold the H key and click and hold like so in order to take advantage of that bird's eye scrolling. And I'll go ahead and hone in on the eyes like so of the Tyrannosaur and then release. And now let's compare that to what would happen if we just zoomed in on the image, which is analogous to just printing the image at a low resolution. So I'll switch back to this guy right here, and then I'll go ahead and change the zoom value down in the lower left corner of the screen to 1,000% and press the Enter key or the Return key on a Mac in order to zoom on in. Then I'll press and hold the H key, and I will scroll over to this location right there. All right, so obviously we've got some big jagged pixels going. I'll press Control-Tab or Command-tilde on the Mac in order to switch over to the upsampled version. Much smoother lines as you can see here, but notice this little region of green right there. We've got some green details that are popping up and some pretty highly saturated green as well down here and up in this region too. And I'm not seeing that shade of green at work in the original image. This is a greenish gray, just a little bit of green, but it's very low saturation, whereas we've got some major green action showing up here. All right, so arguably things look better. This is better than just printing at low resolution, but it's no substitute for capturing a high resolution image in the first place. I'll go ahead and switch over to such a high-res scan. So I scanned this image at 1,000 pixels per inch, which is why it's currently zoomed to just 10%, as you can see here. And it looks a little soft at this ratio because it's not one of the standards. But if I press Control 1 or Command 1 on a Mac to zoom in, you can already see we've got a ton of detail inside this image. I'll go ahead and press and hold the H key once again. Click and drag to about this location again. I'm just trying to get everybody registered into place. And look at that detail. Look at those edges associated with the watercolors. Look at this texture associated with the pencil lines and so forth. So again, for the sake of comparison here, this is the blown up version of the image with the jagged pixel transitions. This is the smooth upsampled version of the image, thanks to the preserve details option. And then finally, this is the real thing right here. So in other words, there is no substitute on Earth for real scanned or photographed pixels, which is why you should always scan at the highest optical resolution provided by your scanner, and you should always photograph at the highest resolution provided by your digital camera. One more thing I want you to note. See this value down here in the bottom left corner of the screen, dock, and then it tells the size of the file in RAM, 1.66 megabytes. The size before the slash, by the way, is the flat version. The value after the slash is the size of the file, including layers. None of these images has any layers, so both values are the same thing. If you can't see this, by the way, then you click on this little right-pointing arrowhead and you choose document sizes. Anyway, notice it's 1.66 megs, so it's dinky. Photoshop is going to have no problems doing anything to this file ever. Whereas the high-resolution version of the image here is 100 times that size. It's 165.9 megs. So it's a monster file. And after about 100 megs, depending on your system, that's when a very big file can start slowing Photoshop down. Just a rule of thumb. And the upsampled version of the file, also, oh, look at that, 166 megabytes. So it's just slightly larger. And yet, it obviously doesn't provide the same degree of detail. So that's why I was saying in the introduction to this chapter that it's not only important to have a lot of pixels inside of an image, but it's important that those pixels are in great shape as well. And that, friends, is the difference between inventing pixels by upsampling and getting the real thing by scanning or photographing at a high resolution in the first place.